Today we're going to be talking about the distance formula. In the past, you've probably just asked, what is the distance formula? And I probably would have just given you the equation. But today, I would like you to ask not what it is, but where it comes from. The answer is quite simple, really. The distance formula comes from Pythagoras' self-titled theorem. If you remember correctly, the formula applies to any right triangle and states that if you square the legs, A and B, then that will equal the length of the hypotenuse C squared. Now let's talk about distance on a graph. If you connected 2 points on a graph on a horizontal plane, it would be fairly simple to count how far apart those 2 points are, and the same applies for a vertical line. However, the same does not apply for 2 points connected horizontally on a graph. Which brings us to our conundrum. How do we find the distance of a horizontal line on a graph? Instead, let us think about how we could connect these 2 points differently. If we draw a line down vertically from the first point and horizontally from the second, we would form a right triangle, which takes us back to the root of our formula, the Pythagorean theorem. So how do we get this equation from the Pythagorean theorem? Let's go back to our right triangle. We know that in order to find distance C, we must find the distances A and B. Remember from before, we established that in order to find distances on a graph horizontally and vertically, you only need to count how many boxes separate those points, hence the difference. So if I gave my 2 points coordinates, x1 and y1, and x2 and y2, then all I would need to do to find A and B is subtract. For my vertical line, I would subtract the y values, and for my horizontal line, I would subtract the x values. So if we return to our original equation, a squared plus b squared equals c squared, and then replaced a and b, we would now come up with this equation. Look familiar? Not yet. If we balanced our equation and took the square root on both sides of the equation and changed c to d, we have this equation. Now that looks familiar. Now that we've explained the origins, let's talk about the formula in practice. If I went back to my line and coordinates and gave them some real values, I could then take those values and insert them into my equation, which would look a little something like this. From here, I solve.